Okay, so for this problem we have a sample of size 5 that is taken from this PDF where f of x is equal to 2x. X is chosen between 0 and 1. And the question is find the expected value for the second smallest of these 5 things, and also find the standard deviation for the second smallest of these 5 things. Okay, so to do this we will use the PDF for the order statistics. So the formula goes that the kth order statistic, if I have n different variables, goes like this: n factorial over k minus 1 factorial n minus k factorial times the density function f of x times the CDF f of x to the k minus 1 times 1 minus the CDF to the n minus k. And this is the PDF for the kth smallest random variable. All right, in my case, I have f of x is equal to 2x, and so the density function, so the CDF would be integral from 0 to x of 2x dx, but I can't use x, so let me use some other letter of the alphabet, t. And this works out to be t squared from x to 0, which is simply x squared. So the CDF is x squared. In my case, I have a sample of size 5, and I'm looking at the second smallest of these things. So plugging in, we have 5 factorial over 2 minus 1, 1 factorial. 5 minus 2 is 3 factorial, times the density function, 2x, times the CDF, x squared, raised to the 2 minus 1, times 1 minus x squared, raised to the 5 minus 2. And so combining these or simplifying, we get this is 40 x cubed times 1 minus x squared to the third power. So that is the PDF for the second smallest of the 5 random variables. Okay, now we have to find the expected value and the standard deviation. Unfortunately, there's no shortcut except to just simply do the integrals and see what we get. So the expected value of x equals integral from 0 to 1 of 40x to the fourth, 1 minus x squared to the third dx, where I take the PDF and multiply by an extra x, so hence the x to the fourth. Now again, there's no shortcut here. This one, we just simply have to multiply out and see what we get. So 40x to the fourth, cubing this, we get 1 minus 3x squared plus 3x to the fourth minus x to the sixth dx. And so that is equal to, well, just multiply it out. And I don't think there's a whole lot of instruction here going through the calculus here. You multiply it out, you integrate, plug in 1 and 0, and subtract. And when you come out the other end, my calculation says you get 128 over 231 when you come out the other end. So we multiply the PDF by x, integrate from 0 to 1, integrate, and then just simplify as best we can. To get the standard deviation, that's the expected value of x squared we get first. So that's integral from 0 to 1 of 40x to the fifth, 1 minus x squared cubed dx. Multiplying the PDF by an extra x squared. So again, we multiply the thing out. Integral from 0 to 1, 40x to the fifth, 1 minus 3x squared, plus 3x to the fourth, minus 1x to the sixth dx. Then we multiply out, we integrate, we add and subtract all the things, plug in 1 and 0, and my calculations say that this works out to be 1/3. And so finally, to get the standard deviation of x, that'll be equal to, or this should be not x, but the second smallest of them. The standard deviation of the second smallest will be the square root of 1/3 minus 128 over 231 squared. And I get this to work out to be about 0.16215. So the mean for the second smallest works out to be about 0.554, and the standard deviation works out to be about 0.162.